Okay, let's use substitution on this one. So we're going to take this and plug it into the other equation for y. So everywhere there's a y, we're going to write it in with parentheses. Of course, it doesn't really matter in this case. It's going to be multiplied. Negative x squared plus 8x minus 16. That's your y plus 4x equals x squared. Just going to solve that. Just get all the x's on the same side and everything. So I'm going to add x squared. So I get 2x squared. I'm going to subtract 8x and subtract 4x. So I get minus 12x. And I'm going to add 16. So I get plus 16. Always take out a GCF if there is one. There is one here. So it'll be 2 times x squared minus 6x plus 8. It should be a little easier factoring. So 2 times x, probably 4 and 2. Both of them must be negative because they multiply by a positive and a negative. So my solutions are x equals 2 and x equals 4. Well, at least I'm going to use those. So now I have to find out what y is when x equals 2. So I'm going to plug it in. So y equals negative 2 squared. Notice the 2 is going to square, not the negative there. Plus 8 times 2 minus 16. So that's equal to negative 4 plus 16 minus 16, which is negative 4. So I have one of the answers here is 2 comma negative 4. And plug in 4 there, so everywhere there's an x, I'm plug in a 4, so 4 squared plus 8 times 4 minus 16 is negative 16 plus 32, this is interesting, minus 16 equals 0. So I have another point at 4 comma 0, just to make sure I did that right. I'm going to plug it in, so it should be negative 4 plus 8 is positive 4, and that works in the first equation. That's 4 and 0. Be 0 plus 16 equals 16. That works in the second equation. Some of these eliminations, you definitely have to line this up here because it's not lined up at all. So I'm going to move this y squared over to the side by subtracting it. So I get x minus y squared equals negative 5. Now I'm going to use elimination. I'm just going to add the y squareds go away. I get x squared plus x equals 20. So let's try that. So this will be going to solve that quadratic. So x squared plus x minus 20 equals 0. Factor that. You get 5 and 4. Plus there, so this will be plus 5 minus 4. So x equals negative 5 and x equals 4. We're going to plug that in over here. Figure out what our y is. In other words, I know I have one is negative 5 comma something. One is 4 comma something. So figure out what those somethings are. So if I get negative 5 there, I get negative 5 equals y squared minus 5. So I add 5 to both sides, I get 0 equals y squared. So square root, you get plus or minus 0, which is 0. And that does work in both equations. Let's plug in x is 4, so 4 equals y squared minus 5. Add 5, you get 9 equals y squared. Take square root outside to get y equals plus or minus 3. So plus or minus 3. So that represents two different answers. And if you plug it in, it should work. 16 plus 9 is 25. That works. So there are 3 different ordered pair answers there. 4 comma 3 and 4 comma negative 3. Use the calculator. Okay. So solve by graphing. So let's solve this by graphing. First, we have to solve for y. Well, this one's already solved for y. This one to solve for y, I would multiply by the GCF, which is 100. So we multiply everything there by 100. Then I get 25x squared plus 4y squared got 25x squared. So we get 4y squared equals 100 minus 25x squared. Divide by 4, divide by 4, divide by 4. Because I did the whole thing, I guess. And 8 square root plus or minus. Okay, so we get, let's go and graph that. I think that's kind of sloppy, but it'll still work. Okay, so we're going to do square root. 100 minus 25x squared all over 4. Let's go and graph it tab. Graph the other equation, so do the negative of that. So it'll be negative square root of 100 minus 25x squared. 4 minus 25x squared. 4. You got like a full ellipse there. That's actually the shape of ellipse. We've studied circles. We haven't really studied these. It's okay. You don't have to know how to do that. Yeah, we'll learn about that, I think, next chapter. About the other equation was this linear one. So if you hit tab and type in 4x squared minus 4. Okay, so I see it does cross twice here. So menu 8. Range, number 4 is intersection point. Click there, and you get the 2 intersection points there. So I guess your 2 answers would be those 2 ordered pairs, right? So negative 1.38, comma 3.62, and positive 1.38. So those are your 2 solutions, approximately, using graph calc. By hand, this should work out a little better, hopefully. I made this problem nice. So negative 1/3 x minus 1, so negative slope, so it goes, if you go down 1 over 3 to the right, or up 1, 3 to the left, you've got your points, it goes through all those nice points there. And it goes through this line here, y equals 1, so it does hit there at negative 6, 1. So that's your solution. Make sure you write your answer there. So you really have a choice here, so I'm guessing substitution, elimination, or graphing. To me, I like elimination, so I'm probably leaning towards elimination. So like this, looks like some pretty big numbers. I'll multiply this one by negative 2 and this one by 3. That should give me the y term should eliminate after that. So if I do that, I get negative 16x plus 6y equals positive 6. And 15x, oh, I like this, minus 6y equals negative 3. If I add, I get negative x equals 3, so x equals negative 3. So I know my answer is negative 3 comma something. And now I'm just going to plug into one of those equations. For x is negative 3, so it'd be negative 15. I plug it right there, minus 2y equals negative 1. So negative 2y equals 14 positive. And then divide by negative 2. Get y equals negative 7. Solve the system of linear equations in Calc. And so I want you to use the Gaussian method here. So you pick any 2 equations, eliminate. Since I already have one variable eliminated there, I'm going to take the second 2 equations and eliminate the z, which means I'm going to multiply this one temporarily by negative 3. If I do that, I get negative 3x plus y plus negative 3y. Erase that. Okay, negative 3x minus 3y minus 3z equals negative 12. I'm going to take this equation, put it down below, so it would be negative x plus 2y plus 3 equals 17. So I'm going to add those together. I get negative 4x minus y, let's go away, equals 5. So now I have this equation and this equation. Solve those two. So how do I do that? It looks like if I just multiply the top equation by negative 1, so if I multiply that one by negative 1, the whole thing, I get negative 3x plus y equals positive 9. I'm going to add, I get negative 7x equals 14. That's nice. By negative 7, get x equals negative 2. Okay, now we can put it back into this equation, say, for x, and solve, so I get negative 4x, so negative 4 times, we're going to do this one right here, times negative 2 is positive 8, minus y equals 5, so y equals 3, so now I know my x and my y. Plug back into, say, that first equation there. No, this is actually, it's plugging the third equation, so we're plugging in this one. So we get x is negative 2 plus 3 is y plus z equals 4. So I get 1 plus z equals 4, so I get z equals 3. So my answer is negative 2, comma 3, comma 3. This one, let's see, I'd like to maybe take the first two equations and add them. So when I do that, I get x plus 2y equals negative 5. That's just by adding the first two equations. I got rid of the z's there. Oh, I didn't see that. I already was missing the y's there. Let me redo this. I think I was like to do things this way. I have to eliminate the again. Let's just do one elimination. So this one, I'm trying to eliminate the y's. So to do that, multiply the top equation by negative 1. And then add this equation to it. So we do that in my head. So negative 2x plus x is negative 3x. Negative y, because that distributes negative y plus y is gone. Positive z plus z is plus 2z. And positive 8 plus 3 is 11. Okay, we take this equation now and do some elimination or something here. It looks like if I multiply this equation by negative 2, that should work. I get positive 6x minus 4z equals negative 22. I take this equation and put it below, so negative 2x plus 4z equals 18. I add, I get 4x equals negative 4, so x equals negative 1. This is nice. Plug that back into, say, this equation here, so I get negative 2 times x is positive 2 plus 4z equals 18. So 4z equals 16. So z equals 4. Got two of the answers. And the third one, which is, let's plug it into this equation. So I get negative x would be 1 plus y plus 4 equals 3. So I got y plus 5, so y equals negative 2. My answer is negative 1, comma negative 2, comma 4. Okay, so matrices, let's take care of this here. So 2 times A is going to be this matrix A. So we've got 6, 4, negative 2, 0. Minus E, which is this guy. 2, 5, 0, negative 4. It looks like I can do it. They have the same dimensions. So my answer will be top left 6 minus 2 is 4. Top right, negative 2 minus 5 is negative 7. 4 minus 0 is 4. 0 minus 84 is 4. 0 times D, 0 times anything is, and if there's 0 when you're dealing with matrices, this will be scalar multiplication, so you get 0, 0, careful. If you square two numbers, you've got to multiply them out. Remember, these are matrices. Okay, so this one is going to be b times c. So this is a 2 by 3. This is a 3 by 2. So and then multiply a 2 by 3 times a 3 by 2. Yes, because the inner dimensions are 3, you can. The answer is going to be a 2 by 2 matrix. So let me write it out so I can see it. 1, 0, 4, negative 5, 2, negative 8 times b is 2, negative 2, 1, 6, negative 4, 5. You do row times column here. So you get top row will be 1 times 2 is 2. 0 times anything is 0. And 4 times negative 4 is negative 16. 2 minus 16 is the top left. Top right is be 1 times negative 2 is negative 2. Plus 0 is plus 20. Bottom left will be bottom row, right left column. So negative 5 times 2 is negative 10. Plus 2 plus 32. And the bottom right, this will be 5. Negative 5 times negative 2 is 10. Plus 12 minus 40. So we get negative 14, 18. So 22 plus 2 is 24. And 22 minus 40 is negative 18. So just to check I got that right, I did check it in the calculator. I'm just want to make sure I answered these right. Some of these is obvious, but that one sometimes it's nice to be able to check. Okay, so now I'll multiply the same two things in reverse order. So that's going to be d is that's a 3 by 2. B is a 2 by 3. Can I do it? Yes, I can. Dimensions matching inside. Dimensions of the answer will be a 3 by 3. Okay, so let's try to multiply this out. So I'm going to write out the 2, 1, 6, negative 4, 5 times 1, negative 5, 4, negative. Okay, so I'm going to do the this one first. So it's top row, so 2 times 1 is 2. Negative 2 times negative 5 is plus 10. This is the first term. Will be 2 plus 10 is 12, I think. Okay. So top middle will be row by column. So the top row is 2 times 0 is 0. Plus negative 2 times 2 is negative 4. So I think that one's negative 4. Top right would be 2 times 4. Top row, right hand column, so 2 times 4 is 8. Plus negative 2 times negative 16, 8 plus 16, which is 24. And this would be 1 times 1 is 1. Plus 6 times negative 5 is negative 30. So I think negative 29. 1 times 0 is nothing. 6 times 2 is 12. So 0 plus 12 is 12. 1 times 4 is 4. Plus 6 times negative 8 is negative 48. Negative 44. And this would be bottom row, so the times first column, so negative 4 times 1 is negative 4. 5 times negative 5 is minus 25, which is negative 29 also. Negative 4 times 0 is 0, plus 5 times 2 is 10, so I think that's 10. Finally, negative 4 times 4 is negative 16, plus 5 times negative 8 is negative 40. Which is negative 56. So just to check my answer. And I did get that one right. Okay, find the inverse, if it exists, of the matrices. Okay, so this is just that formula. It's 1 over the determinant times that mixed up matrix. So 1 over the determinant would be 1 over, let's see, it's negative 21 minus negative 24. So it ends up being 1 that's like over, let's say, plus positive 24, so it's 1 over 3. And the mixed up matrix would be 7 and 3 change place, 7, negative 3, so 7, negative 3. The signs on the other two change, so this would be negative 4. So multiply 1/3 times this matrix. And I get 7/3, 6/3, which is 2, negative 4/3, negative 9. Okay, let's find this one. So this is the 1 over the determinant, so 1 over negative 12 minus negative 12. That's going to be 1 over boom, boom, plus. This would be 1 over 0, which is undefined. There is no inverse. We don't have to keep going. Okay, don't use expansion by minors, use diagonals. It's a diagonal method, which means you kind of write out the first two columns there to the right. So 2, negative 1, 4, 1, negative 2, 2. I'm going to start downwards, so you kind of like circle these three again. So it'd be negative 4 plus the next 3 would be diagonal, would be 12. Next 3 would be negative 7 times 2 is negative 14. So that ends up being negative 18 plus 12 is negative 6. Now the other way, so if you multiply those up, negative 8 times 7 is negative 56 plus 6 times 2 is 12 plus negative 1. Negative 57, negative 55, negative 45. So it should be, the determinant should be negative 6 minus 45, minus negative 45, which is positive 39. So I think the answer should be 39. And I checked it, that is correct. Diagonal this way, so this will be 1, 2, 0, 3, 0, 2. So diagonals, you get, well, this is easy, 0 plus 0 plus 14 times 2 is 28. If you diagonal the other way, you get 0 plus 16 plus 12. 16 and 12 is 38. So we end up getting 28 minus 38, which I think is negative 10. Negative 10 should be the answer. And in case you didn't know, 16 plus 12 is actually 28. So this is 28, which means 28 minus 28 is 0. So sometimes it's easy to make even just a small error in arithmetic on these problems. Okay. Use Cramer's rule to solve. You got to set it up to, I know you use Cramer's rule, but then you're going to, the Nspire will do the determinants just fine for you. So Cramer's rule looks like this. So x equals the determinant of the coefficient matrix here, which is 1, 3, 1/3, and negative 2. Up top, 3 and negative 2 stay in the same spots, but I'm solving for x. I'm going to replace those with these two variables, 4 and negative 3. Set up my y. The top will be 1 and 1/3. Just 3 there. 1 and 1/3. On the right will be 4 and negative 3. And I'm just going to use the same determinant I got for the first one. So let's figure out what those things are. So let's get a calculator out. If you don't know where determinant is, menu, you probably enter matrix, and there it is, number 3 determinant. I want to put a 2 by 2 in there, so I'm just going to do a 2 by 2 template right there. Again, 1, 3, 1/3, and negative 2. it's -3 down there. And the thing I like to do in the calculator is you copy and paste that coefficient matrix, just change the two I need to. When it's x, I'm looking for, I'm going to change that to 4. I get 3. I get 1, so x is -1/3. I go back to the coefficient matrix this time. I'm going to change or alter the y value to -3. So I get -13/3. Okay, so don't forget to write your answer as an ordered pair. Here, with my x's, I just set it up. I need to replace the constants go in the x column, so this would be 6, 4, 0. Here in the y's, it would be in the middle column, 6, 4, 0. And here in the x's, it'll be 6, 4, 0 in the z column. And I'm going to do these separately on the calculator, so if you haven't done this before, you definitely want to go the separate route here. So I'm going to find the determinant. Let's do a 3 by 3. Let's start with the coefficient matrix every time. Always the best to do first because we can reuse it. When we use the calculator, we copy and paste, make less errors, hopefully. My coefficient matrix is going to be simplified to 5 for the determinant part of that. So let me go back to this. Replace the x values with the 6, 4, 0, 6, 4, 0. That's 26/5. Start with the coefficient matrix. Replace the y values with 6, 4, 0. Get 10. So y will be 10/5. I'll come back to that in a second. And determine copy and paste the coefficient matrix. Change that one to 6, 4, 0. And -10. So the denominators are the same, they're all 5. I don't rewrite the matrix every time, it's too much work. So again, the x value is 26/5. The y value is 2, and the z value is -2. Well, that really worked out weird. Let me just double check that one. Just because one of them is a fraction and one of them is. So I'm going to retype just that one just to make sure. So the coefficient matrix, this one, it probably is right, 6, 4, 0. Ah, I must have typed it in wrong. 40/5, which is 8. Now you can check that answer to make sure it works. Use the equations here, so 8 minus 6 is 2, 2 plus -2 is 0. That works in the last equation. I'm thinking it probably works, so that is our answer there, 8 to -2. Phew, got that one. This one's largely done in the calculator. Again, I just want you to set it up so I know you know the method. So the A would be 1, -6, 3, and 2. The inverse means that's the inverse of A, times the coefficient matrix, which is 3, 1. And the answer should be our answer here. So you do 2 by 2, like that. 1, -6, 3, 2, times 2 by 1 matrix. 3 and 1. So x is -3 and y is 11. Largely done in the calculator. All the work I need you to show so I know you use the right method. Here we're going to take the inverse of the coefficient matrix, 4, 5, 4, 7. -3, -6, +10. Wait a second. Something's wrong. If you're not paying attention, you might miss this. So there's really a 0 there for the x. These two are connected. These two are connected. This x goes with this one. These are the x's. The y's are here. Wow, that's really weird. It's zeros for the y there, if that makes sense. So zeros for the z, I think, there. There's the z. Okay, so let's put these in the right order. So as far as x, y, z, this could be 5, negative 3, and 1. In the second row, the x, y, z is 0, 4, and negative 6. And the next row is 7, 10, and 0. Inverse of A times B, which is the constant matrix, 22, negative 13. At this point, you just type in your calculator. By the way, I realized, fortunately not too late here, this should have been to the power of negative 1. It should be the inverse of A. I just did A times B. So your actual answer is 3/5. Kind of like negative 2/5. I could have checked that. Always a good idea to check your answer. You'll catch those kinds of mistakes if you check your answer. So 3/5 minus 12/5 is negative 9. 3/5 plus 12/5 is 15/5, which is 3. That does actually work. So that one does work, at least in the first equation. I'm pretty sure it works from there on. Let's show that, just to make sure you know how to do that. So let's do 3 by 3. Sometimes I'm sure so concerned about typing everything in correctly, you forget to do like the inverse of it, right? That's how this method works. So it's a good idea, I don't know if you caught that, to check your answers. Negative power 3 by 1, so it should be a 3 by 1. 6, 22, and negative 13. And so I get 1 times negative 2 times negative 5. Let's just make sure that works. So 5 plus 6 is 11, minus 5 is 6. That works. So I'm pretty sure about that. So this is the last one. Just as a hand, just good practice for you. Again, there's going to be a 10-point extra credit problem on the test. So I'm going to first do the minors. So to get that, you kind of like mentally cross out row and column there. 2 times 1 is 2, minus 4 is negative 2. Top middle will be 2 minus 8 is negative 6. Top right will be 1 minus 2 is negative 1. I hope I'm doing this right. 2 minus 0 is 2. 4 minus 0 is 4. 2 minus 2 is 0. And bottom left would be 4 minus 0 is 4. 8 minus 0 is 8. And this would be 2 minus 1 is 1. And we do the cofactor, which means we change the sign. Well, I'm just going to change the sign on this one, change the sign on this one, change the sign. 0 there doesn't change, but it would change. Those 4 kind of tic-tac-toe, kind of like between the things there. So just these 4 terms change. Okay, so now we have to transpose each row and column. So my top row will be my first column, negative 2, 6, and negative 1. Second row is my second column, so negative 2, 4, 0, and 4, negative 8. Now you have to take the determinant of the original matrix. So I'm going to do that with the diagonals method. So this is going to be 2, 1, 2, 1, 1, 1, 0, 4, 2. 2, 1, 2, 1, 1, 1. So going diagonally here, first this way, so it's going to be 4 plus 8 plus 0. Going diagonally the other way, it's going to be 0 plus 8 plus 2, which is 10 and 12. So it should be 12 minus 10, which is 2. Okay, so that means I multiply everything by 1/2 here. So my final answer should be -1, -1, 2, 3, -1/2, 0, and 1/2. And I just checked with the calculator. Unfortunately, in tests, you can't do that, but you could check by hand. So you want to be sure you get it. Multiply this guy times this guy, and you get the identity matrix, which should be the one, which should have all those diagonally. So those for the rest of them, if that makes sense. Zeros for all of these guys. So if you get the identity matrix when you multiply this one times this, you know you did it right, and I did do it right there. So practice that. You get to get that 10 points.